Thank you, Nariman, for this meeting. And please, you can start.
Thank you so much for the nice introduction. It's really nice to meet all of you tonight. I am very pleased and honored to be here. I will use this slide to talk a little bit more about myself. I am a postdoctoral fellow, or maybe another term is research scientist, working with the University of Tennessee Health Science Center. I am in the Center for Biomedical Informatics, and we are affiliated with Oak Ridge, and we're also working in the research tower of La Bonheur Children's Hospital in Memphis, Tennessee. We have a lot of research groups within the lab, but I am working in the Population Health Intelligence Lab. We are multidisciplinary. As you can see, we have social scientists, mathematicians, logicians, data scientists, and health education and promotion professionals. And we apply machine learning, but we also apply semantic web technologies to do what we call explainable artificial intelligence. And that's what, in a sense, what I'm going to be talking about today. So explainable artificial intelligence using knowledge graphs, basically. And this talk is based on a research paper that I published recently in Journal of Medical Internet Research, in particular, Journal of Medical Internet Research, the Medical Informatics sister journal, let's say. And the paper is about, as I said, explainable AI applied to an application or a proof of concept of an application for screening for issues related to adverse childhood experiences. So it's more on the mental health surveillance side. And so it's a recommender system and a chatbot, and it's a proof of concept prototype. The motivation for this work was based on an initiative that started at La Bonheur Children's Hospital. La Bonheur we are located in Memphis. Memphis, Tennessee is a small city. It has an interesting demographic distribution. It has a lot of African-American population, and it suffers from a lot of issues related to poverty, especially in the Memphis metropolitan statistical area, which covers parts of Arkansas, Mississippi, and also mostly Shelby County within Tennessee. And this program started about 2 years ago. It's called the Family Resilience Initiative. What they do is, after the primary care visit of parents coming with their children, they voluntarily go to another interview where they ask them questions. They have like pretty standard questionnaires, and those questionnaires are long, and they are somehow one size fits all. So they have to ask all these questions to every single caregiver or parent coming into those visits, and they just answer yes or no, and they just go through those questions one by one. And then some of them, they're in a sense coming for support, basically. So they do screening, but they also they have a strong referral network, so they kind of refer them to some community partners that they already partnered with, and they do things like follow-ups on appointments, or they do referrals, and sometimes they provide material, sometimes food, food pantries and stuff like that. Some of these families actually also volunteer for research. So we're also collecting information to do also research studies. But what I wanted to do with this is to read through their reports, and they have like these quarterly reports where you could read statistics, but you could also read anecdotes. So they provided anonymous anecdotes of some of the client cases, and I kind of went through those stories, and I tried to come up with a tool that could potentially in the future automate the screening process and the referral as well. And so in the rest of this talk, I'm going to be referring to adverse childhood experiences as ACEs. And these are things that are related to, child behavioral issues or developmental health. There are several categories under this. And the other thing is social determinants of health, which is a big deal these days, because when we study social determinants of health, it's not really the clinical aspects that affect a certain negative health outcome. It's the other social environmental factors that affect those populations. And some examples of these social determinants of health, or SDOH, as I will refer to this in the rest of the talk, are issues with housing, food insecurity, transportation, education, legal benefits, things related to legal issues and stuff like that. And as I said, they also have follow-up activities, and these are either predefined or they just come up as they develop more and more of these reports to look into more cases. And so, as I said earlier, because the current process is not really automated, they do have a portal where they, the parents kind of answer questions, but it's not really intelligent in a sense that there is a lot of effort in data entry, either from the healthcare professional or social workers, whoever is sitting behind this tool in data entry. And there's also an issue with, okay, so we collect all this knowledge or all these information, what do we do with it? We have to analyze it and benefit from it. And we need, this is one of the issues. And also in mission critical area like medicine, if you want to tell the healthcare professionals that you should make this decision, which, what machine learning techniques usually help them do, make this decision, or, the result was like this, you have to make this decision. But with this, area of research, you really need to provide explanations. How did you come up with this, decision? Why should they trust us? So there are issues with transparency and accountability. And as I said, these questions are predefined. They have been there for years, and there are published research papers about what they should ask about in those adverse childhood experience questionnaires and social determinant health questionnaires, but they are overwhelming and sometimes irrelevant to some caregivers about their children. And sometimes there are even hidden issues that are not being asked in those questions. There are hidden issues in the environment that we do not know, and we would like to uncover during the conversation. So there are tools out there. I know there are universities that are working on similar tools, but these tools help spot the issue. They help in the screening, but what about navigation? How do we navigate those in need to resources in an intelligent way? And once we make those recommendations, do these tools actually take context into account? And so to mimic human intelligence, one of the most important aspects that we can use is context. And context in the context of this talk is using semantic web. That's what we are using to make the conversation more relevant to the current user. And as I said, once we make those recommendations, we would like to explain why. And if we use semantic web and knowledge graphs, this native knowledge graphs are natively data structures that can be used for explanations. We can just trace back on a graph in order to explain why we made a certain decision, and that's what I would like to talk about today. And so just briefly, I know knowledge graphs and semantic web. I know this is like a very trendy term, and maybe many people in the audience already know what a knowledge graph is. But the way I wanted to, to talk about it, or define it in the context of this talk, is a way to provide explanations in artificial intelligence. And there have been several we have been using classic machine learning and artificial intelligence for years. And the way machine learning works is we have some data sets, probably pre-labeled, and we use this data set to train a certain machine learning model. And once we train the model, that model becomes intelligent enough to make predictions on unseen data. So we train it on a set of data, and then we use it to predict some outputs, classifications, or decision trees, or deep networks based on unseen data. That's how classic machine learning works. But the problem with machine learning is we don't know so much about the underlying mechanisms behind those models. We don't know what's going on, except for some of them, like decision trees. And there has been like an inherent tension between precisions and transparency or explanation. So it's either or. And so knowledge graphs are a way to kind of open the black box in classic machine learning. So it's a way to open the black box and provide transparency in terms of explanations. And that's why I wanted to use this to provide explanation. Now, the way I define knowledge graphs, because I saw in the chat, some people said they're not familiar with it. And it's not my definition. I'm part of a knowledge graph community that started in May 2019. And I will also share the link to that Slack channel. It's a very, very rich community, and it has people who are really knowledgeable in the field. And what everybody is talking about in the group is that semantic, in the past, we've been talking about semantic web and semantic technologies. And recently, what people are trying to do is that they're trying to talk about knowledge graphs in the context of semantic webs. And so what they say is we have context, which is the semantics, basically. So when we say, dogs like meat, for example. So dogs in this context, the word dog can be labeled. We can say a dog is an animal, and likes is a predicate, and then meat is another thing that refers to food, for example. And so it's a way of giving meaning or semantic to certain text, for example, in a given context. And there are so many, there have been so many efforts to come up with knowledge graphs. Google has their own knowledge graphs, Microsoft, Amazon, and these big giants, they already have, everybody is defining their own knowledge graph, and they use their own taxonomies, and we call them ontologies. And in these ontologies, they define concepts and hierarchies and relationships between terms. And that is not really data. It's just a way of describing concepts in a certain world, in a certain context. And sometimes the same word could be used in two different knowledge graphs or in two different ontologies, but they mean different things in different contexts, depending on the application scenario. And these contexts could be either application specific or domain specific or upper level. And so this encourages the community to kind of reuse, especially in healthcare. There are ontologies for diseases, there are ontologies for mental health, and people can actually reuse each other's ontologies and import them in their own ontologies and define new taxonomies. So it's an effort to provide context. Now, a knowledge graph takes those concepts and adds data to them. And once we add data to those concepts, it depends on the application. Again, in our application, we need data, and we collect this data from conversations, for example, with those parents. And so we have concepts and taxonomies, but as we go through the conversation, we want to load those concepts with data. And so we consider those data as facts. It's something that the user says, or it's something that we collected through studies, or it's something that we actually analyzed, and now we kind of did feature engineering. We added the results to the data set, we enriched the data set. So we have evidence or facts or data, and we use the semantic taxonomies to provide context about this data. And so in the context of this talk, a knowledge graph is really, it's a semantic graph that is also loaded with data. And the context, we provide context through semantic technologies. And I'll explain specifically how we did this as I go through the talk. And as I said, we use knowledge graphs to provide explainability in AI. And the nice thing about graphs, not necessarily knowledge graph, but graphs in general, they enable us to generalize based on structure, not based on data. Because as I said before, when people do machine learning, when people use machine learning on data science studies or analysis studies, the goal is really to generalize. So we have a set of patients from a hospital in Memphis. They have severe sepsis, and we come up with results. We say severe sepsis is associated with lack of money. But this is just based on a small subset of patients, and they are within a certain age group, living in a certain city. But what we are really trying to do is we're trying to generalize. And so somebody can take the results and replicate them on another population, and they might either get consistent results that agree with previous literature, or they might get different results. And so, the goal of machine learning is to generalize. But the problem with that kind of research is it generalizes based on the data. And when we use knowledge graphs, we generalize based on structure. And I will talk about this, how I reason about this later. Now, in terms of applications, when we say knowledge graphs open the black box in AI, two of the most popular applications that utilize knowledge graphs are, let's say, two classes of applications are digital assistants or chatbots or question answering systems. And the other class of applications is recommendation systems. And in this prototype, I wanted to provide a recommendation service, but I wanted that recommendation service to feed those recommendations into a chatbot. And the role of the chatbot is to really talk to the person behind the application. So if it's a social worker, or if it's a caregiver, depending on the application. But because I was applying this to Labanner's Family Resilience Initiative, this was in the context of mental health surveillance. So it's a chatbot that talks to a caregiver, and it asks them questions to kind of slowly uncover their problems, uncover hidden issues, ask them only questions that are relevant to their case, not to go through the whole list. And so digital assistants incorporate knowledge graphs into dialogue interactions. And there have been several papers and applications on this, as I can see through our knowledge graph community and through papers as well. And the input to those applications is usually, as I said, it's data. So when we chat, it's user utterances, basically. People are talking or texting, typing. And then as they type or as they talk, we want to capture the data because this is a fact. This is something that they actually say. And we want to attach that data to context, which is the semantics. And we use semantic technologies to do this. And once we have the data and context, they serve as parameters to queries, because queries, any kind of query, SQL or Sparkle, for those of you who are familiar with semantic web, there's a query language called Sparkle. And so for any kind of query, what we really need is an entity type. We want to search for all patients in a certain hospital whose name starts with A. So we need to formulate queries at the end of the day. And so what I really want to do through the chatbot is to capture the data, attach it to concept, feed those into queries, and then run those queries in a knowledge graph. And I want that knowledge graph to be personalized to the current user. And I call it a personal health knowledge graph. The other application, which is the recommendation system, uses those, when we run those queries on the back end knowledge graph, we get results. And we want the recommendation service to use the query results to get all possible solutions to this user based on their problem, and then kind of filter those solutions based on certain things that we detected in the conversation, like their zip code or their age, or it's not really their age, it's their child's age, or it's their child's zip code, because these are the caregivers talking to us. And so this is pretty much what I wanted to talk about. And so this is, I call it an approach for AI explainability. And this shows what we really do. I tried to come up with this picture based on what we do in the lab. So basically what we do, what you see at the very bottom is, I don't know if is the slide trimmed from the bottom, or is it just me? Can you see the bottom?
We can see the property hub at the bottom.
Perfect. Yeah, perfect.
I know.
Yeah, so we basically, we collect data from US Census. We collect data from Esri software, CDC website, US Department of Agriculture. They're local partners. There is a local partner we're dealing with called Memphis Property Hub. And what these data sets provide, for those who are familiar with GIS, or those geographic information systems, what we do is we get data that is already available publicly, or if it's not public, if it's pretty much private data, we get them from local partners with some restrictions. But what that data looks like is it has a neighborhood, so it's either the certain person's address, so it's the individual parcel, or it's a census tract or census block or a zip code. So there are different geographic granularities that represent the notion of a neighborhood. And we call these public or neighborhood population or neighborhood level data. It's data about poverty, about access to resources like distances to hospitals and community parks. It could be percentages of the population who live in that census tract who do not have a car, or who live within a certain number of miles from a supermarket or a healthy food resource. Things about food deserts and so on. And we collect this data, we keep it in a repository, we call it Population Health Observatory, and we do cleaning, analysis, and we keep the most important variables that we really care about. And through different studies that we conduct in the lab, if we're conducting a study on children with severe sepsis, for example, we use the patient's address to geocode that patient into a certain geographic granular, like a census tract or a zip code. And then we merge all those social determinants, the environmental aspects, with the patient's record, and we try to look for pathways between those social determinants of health and their negative health outcomes. And as we do more studies, we have evidence. We have evidence about how certain social determinants lead to certain negative health outcomes. And once, so that could be, an Excel repository or a database, or, it's a data layer. And then on the top of that, you can see the semantic web technologies tier, where we do things like knowledge mapping, semantic inference, capture contextual knowledge, aligning group level or population level data or evidence or facts with individual or patient level evidence. And we do all of that in the semantic layer. And then once we have the data or the evidence and the context attached to that data, we can query that data through some API. It depends on the application. It could be, a REST API. It could be a Sparkle query. If it's a knowledge graph, we use some sort of graph technology like Neo4j, for example. If we want to do federated querying, we use things like LDFlex. So there are different ways we can actually query that knowledge graph based on a certain scenario. And then on the top of that, we have a layer of explanation. So if depending on the kind of analysis that we conduct, so if we do spatial analysis, we could provide maps that show clusters of problems, or we can show among those clusters which are the high-risk groups. Or if we do regression analysis, we could show correlation coefficients and p-values of significance. If we do causality analysis, we can show causality graphs or inference paths. So that's where we keep the explanations. And depending on the application, if it's a chatbot or if it's a recommender system or if it's a dashboard, in the case of COVID, for example, we can show results of these analyses. Depending on the application, we can show different types of information using different visualizations. If it's a map, it should be a map. If it's a graph, a regression graph, we can show a graph, and so on. And in the context of this talk, the application was a digital assistant. And so we wanted to just chat with the caregiver, and we wanted to show the healthcare professional or social worker explanations of why we made certain decisions. Now, because this is not a research conference, I just wanted to give a quick overview about the tools that I used as I was developing this prototype. So for developing those taxonomies or semantic taxonomies, we usually use softwares like Protege. Protege is used to design ontologies, any kind of ontology really. And within that software, we can define domain-specific concepts. So we have concepts, and then we have concept hierarchies. If we have a disease, we have like certain kinds of diseases that fall under this category. And we can also define concepts and sub-concepts, so concept hierarchies, and also axioms, relationships, inference relationships. And in the context of public health, we call them epidemiological axioms. And I'll talk about some of these later on. For developing, now this is for designing the ontology. For developing the chatbot, I used Google Dialogflow. The reason why I used Google Dialogflow is because I wanted to access Google Cloud Platform APIs like Google Calendar, Google Maps, Google Places, because they were relevant in the context of this application. I also used, at the time of this, when I built this app, I used Neo4j, and the reason why I used that because it's a popular graph database technology, but recently they also incorporated a data science library, so you can do a lot of the graph algorithms from within the Neo4j environment or the API. So and this is something that I wanted to do. Because the ontology was in a certain format, and I'm not sure how much you're familiar with the difference between an RDF graph and a property graph, but Neo4j produces property graphs, and ontologies produce RDF graphs. So I wanted a way to make the two talk together, and I used certain plugins that work with Neo4j, such as Semantic, which transforms an RDF graph into a property graph. I also, for certain things, I wanted to get common sense knowledge, like to do knowledge enrichment. So, I start with a minimal number of nodes, and I wanted to kind of expand the nodes. So I used, also from within Neo4j, I used the Microsoft ConceptNet 5 to get, and I provided links to those in the presentation as well. Before we started working on this application, one of my colleagues, as I said, has designed an ontology using Proto.j. And this ontology, going back to the topic of the talk, he designed a comprehensive ontology that covers concepts and concept hierarchies and epidemiological axiomatic knowledge related to adverse childhood experiences and social determinants of health. And so in that ontology, what he did is he encoded concepts related to social determinants of health and anything that falls under those social determinants of health. And for example, things like quality of housing and things related to food insecurities or nutrition issues. He also encoded concepts related to adverse childhood experiences, things like abuse in the large, and then all the subtypes of abuse, sexual abuse, physical abuse, and also things like neglect. And under that, he encoded things like emotional neglect. And so all the concept hierarchies, this is just a conceptual view. And then he encoded concepts related to negative health outcomes. So somebody raised their hand. Is this like an interactive talk or?
Actually, we are going to have the question and answers at the end.
Okay.
Yeah.
Thank you. So and he encoded concepts related to negative health outcomes, and this is in the large because negative health outcomes could be things like diseases, and diseases could be chronic, infectious, etc., and even things like stress. So this is a negative health outcome. It's not really a disease, but it's a negative health outcome. So any concept that comes under those, and lastly, he encoded concepts related to interventions. And interventions, you could really think of those as follow-up activities or recommendations on things that you could do to approach a problem, to solve it or mitigate it. So it's a term used in epidemiology and public health. And so interventions could be either therapeutic. So if you detect in a health, a disease, for example, in the conversation, if this child suffers from a certain disease, you could actually refer them to a pediatric asthma doctor, for example. And so the intervention in this case is to schedule an appointment with a pediatric asthma doctor. The preventive interventions are more like, interventions that are more intended for policymakers to, depending on the problem detected, we can just take a note of it and then maybe give a recommendation for policymakers for building a school in this neighborhood because there were issues with education, or things that could focus on the literacy level of the parents so they can help their child, and so on. So it's not necessarily curing a disease. So interventions could be either or, and anything that comes under those Jan, my colleague, included in those ontologies. Now the question is, how did he decide on the concepts and concept hierarchies and axiomatic knowledge? He actually referred to research papers. He reused existing ontologies or taxonomies, like disease ontology is already there. In terms of adverse childhood experiences, he referred to the questionnaires, the standard questionnaires. He also, so research papers, standard questionnaires, and he also benefited from expert opinion. So he had interviews with certain health professionals in the hospital. And he also benefited from the Family Resilience Initiative reports as well, and the entire team. And he also published this paper, and he also he has the ontology on BioPortal, which is a repository for all ontologies that researchers can actually reuse and build on top of each other's ontologies. Now, going back to this diagram, I finished this part about designing the ontology. Now I want to move to how I worked in the conversation agent, or the digital assistant, or the chatbot. And as I said earlier, because this is a knowledge graph-based application, I want to capture data and context. And what chatbots can really do, this is what chatbots really do. They detect certain words in a conversation, and they kind of want to answer questions, either ask follow-up questions, provide a solution. And all of us are familiar with this from maybe chatting with Xfinity or, one of those companies to solve a problem. And I think most of these companies, they rely on probably predefined plain text documents or HTML documents of frequently asked questions, or somebody works on those documents, and there's some sort of a tree of questions that we can go through in order to automate the screening process. And what I tried to do here is something similar, but because we did not want to use the standard questionnaires as a way to do this, because this is not going to be intelligent anymore. We wanted to go through the questions, but then diverge depending on the situation. Now for the QA agent, what I did is I used Google Dialogflow, and I'm not sure how much familiar the audience is with this or with things like IBM Watson, but I think they pretty much do the same thing. The first thing you want to do is to define an agent, and an agent is going to do the question answering. Now the agent itself, Google Dialogflow is pretty mature in two things: in building a machine learning model and training the model. They already have a training component, and they also have a mature natural language processing component. That wasn't something that I actually, I did not like reinvent the wheel or work on that. They already have that built in. But what I did is I had to tell Google that there are certain words in the conversation that I want you to detect as either adverse childhood experience or social determinant of health or negative health outcome or intervention. And so these were not really common sense. They might be in some taxonomies, but I wanted for this to be an application. And so we wanted to use the ontology that Jan developed as an application or domain specific ontology. And another thing about Google is it's also mature in detecting things like zip codes and age and sex. So they already know all of this. I just wanted to tell them about the concepts that we have. And so the first thing you want to do after defining an agent is start training the chatbot. And the other question that came to my mind is, how do I train it? Where do I get the text from? And that's where the Family Resilience Initiative quarterly reports came into play. We used some of the anecdotes because they were anonymous. We used some of the anecdotes to train the model. It took some time for the Google Dialogflow to catch some of the terms, but it eventually worked. And I'm gonna show you one example of, so for example, one of the training phrases was, taken with some, tweaking from the report is, a woman who said in the conversation, my husband is alcoholic. And then she said things about her child being hard to soothe. And she mentioned that he's a 4-year-old baby boy. And she goes on mentioning another things that he does that she considers to be problems for her. And then at the end, she says this causes a lot of stress. And so we wanted, in addition to Google being able to detect boy as a gender or 4-year-old as an age, zip code as a zip code, we also wanted Google to realize that alcoholic is an abuse, and it's in particular it's a substance abuse, and the things highlighted in brown as symptoms in according to our ontology. So these are symptoms, and stress according to our ontology is a negative health outcome. And so these are the things that I had to do in Google Dialogflow gradually by feeding more and more phrases and labeling some of these words with what Google calls entity types. And so the things coming from the ontology of entity types and the values appearing in the conversation, they call them contextual parameters. So these are parameter values. And so what you see on the first column is the parameter value. And sorry, what you see in the second column is the entity type, and what you see in the third column is the value. So these are the parameters and their entity types. And if someone else comes into the conversation and says something else, like sexual abuse, sexual assault, then that's going to be detected as an abuse, but it's going to be, sexual abuse. And so it really depends on the sentence. So this is the first thing that you want to do when you define your agent. You want to go on providing some examples of text that could potentially appear in the conversation. And Google starts detecting those entity types and giving them parameters from the current conversation. Now, the other thing that happens within those chatbots, and as I said, Google Dialogflow is just one example, is this thing called parent-child intent detection. And this is not really, again, this is not really something that I came up with. It's Google does this, but I had to go and say, well, this application is an application for providing recommendations, and I call it Family Resilience Initiative FRI_recommendation. And so the main intent in this conversation is I'm just gonna, because I wanna point out two things. So the main intent in this conversation is the FRI recommendation. So this person is really looking for recommendations. Now, as the caregiver starts talking, so they're coming for recommendations, but if they start talking about things like mold, bugs, inadequate heating in their house, then this is no more generic recommendation. This is a housing recommendation. So it's a sub intent. The general intent of the conversation is to look for recommendations, but when we get more details from this user, this is a sub intent. So this is a child intent. Housing recommendation is a child intent of the generic recommendation, and so on. And we keep going further until we get deeper. So I have to, as a chatbot designer in Dialogflow, I have to define these intents. And I have to define which is the parent and which is the child. And once I do that, and I have already done the training, Google is going to pick up the pattern. So it's going to start, when we start with the conversation, it's going to start with the parent intent, and it's going to start detecting sub intents until we reach a point in the conversation where we actually have a solution. Now, the other aspect here is as a chatbot or as an agent, the agent has to keep track of all active intents, and they call them contexts. So all active contexts should be kept on a stack. And when we resolve one, we have to go back and resume the conversation. And so intent detection, parent-child intent, and then context detection. And within this context detection, if let's say the user is talking, so what you see to the left is what appears on the interface. So this is what the user sees, and to the right is what happens behind the scenes. So, when the person provides a lot of details, like their age, their zip code, etc., Google does not have issues. But if the person is being very vague, we could, in a friendly way, we could define something in the background. We call them slot filling context parameters. And so what you can do is you can say, well, if the person does not provide, if let's say in the conversation we reach a stage where we want to schedule an appointment and the person does not provide a date, duration, time, or the type of appointment, we can trigger them in a friendly way to provide those information. But in the back end, we specify those as mandatory parameters. And so within a given context, if let's say we started with a very generic recommendation, we went to housing, and then down in the conversation, we reached the intent that is related to starting on a follow-up activity, because we reached a stage where we want to provide a solution, and we say, hey, we realize that your problem is with housing. Now we want to schedule an appointment for you to talk to a housing company, or someone who can solve your problem. We want to reserve an appointment for you, and you did not provide these details. Could you please go ahead and provide them? And as they provide them, we can start filling those parameters with values. And this is another issue that could appear in the conversation, because some people are vague, some people are detailed. And so we could, if the person provides values for parameters, we will go ahead and detect them. But if not, we can actually trigger them to provide those intents. And this is another thing that I did. So training the agent, and then the intent detection, parent-child intent definition, and the slot filling contextual mandatory parameters. This is another way of showing how the chatbot should keep track of all active contexts during the conversation. So this is the same example, it's just a different way. It's like a flow diagram of how things happen. And here I also would like to talk a very, very nice feature in Google Dialogflow. So because this is the Google Cloud Platform environment, Google Cloud Platform is just it's an umbrella for so many APIs, and Dialogflow is one of them. Google Maps, Google Calendar, Google Places are other examples. And so when the user starts at the top and they say, I have issues, as I said, this is considered general FRI assessment, intake assessment, or recommendation intent. But then we can start triggering some questions to kind of keep the conversation going in a certain direction. And so we could ask them for their zip code. If they provide their zip code, we can ask them about what exact issues they have. If they say housing or transportation or child behavioral issues, we could just focus on one. But if they say all of them at once, we have to fork, we have to take one at a time and start asking them, is it, and I'm sure all of us see this when we talk to Xfinity, right? Is it your account issues, or is it, billing, etc.? And depending on what they choose, we could just focus on that aspect, and that becomes the active context. And that's what I meant by the active context. And so what you see here is, a certain context. So here, for example, because they did not provide the zip code, we activate the slot filling context. Once they provide the zip code, we can go with either housing or transportation. So this becomes the active context. Throughout the whole conversation, we know that this is in the large, this is the FRI intake assessment or recommendation context. It's not, especially if you have different applications in Google Dialogflow. Now, the nice thing about Google, because I'm using Google Dialogflow, is if let's say we reach a stage where we want to start reserving an appointment, we tell them, okay, we want to schedule an appointment, give us time, etc. What we can do is we can invoke the Google Calendar API to kind of trigger the calendar app on their side. And like once we reserve the appointment, we can add it to their calendar, or we can ask them if they want to add it to their calendar. So that's something I thought of when I chose Google Dialogflow. Now, how do we do this? In Google, there is something called the fulfillment. And what you do is from within the Google Dialogflow interface, you could actually write, they have a certain syntax where you could actually invoke a certain service or API, either from Google or your own service. And because I wanted to detect the data or the facts or the evidence, attach them to context or entity types from the conversation, and I wanted to lay this over to the recommendation service in the back end to talk to the knowledge graph and formulate queries, I thought that maybe I need to define my own API, my own REST API, and then just publish that API on Google Cloud platform, and then come to the interface here in Google Dialogflow and just invoke my API, the one that I already defined. So within the fulfillment, you could actually define your own service and invoke it, or you could invoke one of Google's APIs. And it depends on some of these services are paid, but this is what the fulfillment is, and this is something I liked and I wanted to find out. So this is what we do in the chatbot. Now, going back to our diagram, so we're done with the ontology. We tell the QA what are the concepts that we need from the ontology to be able to detect the context in the conversation, attach those contexts to parameter values, and then formulate queries, use fulfillments to lay those queries over to some backend service. And in my case, I call it the personalized knowledge graph generation component that will later on give results to the recommendation service. Now, within the knowledge graph generation, I just wanted to show you how quickly on some example, how I generate the personalized graph in different steps, and how I populate those concept hierarchies with data. To do that, I will just use this scenario that, let's say someone, a caregiver, female, Hispanic female, talking to a social worker through this chatbot. She says something like, I'm Hispanic female living in Memphis in this zip code. My 6-year-old child experiences night terror. I don't have a car. Let's have this hypothetical scenario. Now, because this is not really intended to be an, she doesn't really have to log in or anything. This could be anonymized. So we create this dummy node for this woman. We call it an individual, for example. And then what we do is we start by detecting anything that we saw in the conversation that is considered a fact or evidence. So this is something she provided. She provided that she's Hispanic, her zip code, etc. And that's what we know. The other thing that we know from the conversation is, as I said, so these are the contextual parameters. I'm using the Google Dialogflow terminology. And these are the entity types. So Hispanic in this context is a race. 38103 is a zip code because it could be a number in another context, right? So it's a zip code. 6 in this context is an age. And night terror in this context is a symptom. Now, if you ask why I have different colors, so what I wanted to show here is that the things in purple are really the contextual parameters that I detected or Google detected on my behalf in the conversation using natural language processing. The things in gray are the things that could be common sense, either because Google already has predefined system types, because as you saw here, for example, if you notice here, sys.age is something that Google detected, and they prefix this with a sys term because this is something from their side. This is not really from my ontology, even though I could encode it, but they already, people do not really need to encode all of this. They could either reuse something existing from other ontologies, or they could rely on frameworks or some common sense knowledge graphs like ConceptNet 5, for example. And so I wanted to differentiate between those nodes. The things that you see in blue is what my or our ontology provides. So anything beyond the purple nodes are not really values. They are just labeling those values with concepts. So this is the context that I was talking about. So zip code, age, etc. That's something that maybe Google gave me, but it's a concept. It's not really a value. Now, things like, for example, night terror is a symptom. So that's something in the ontology that we capture in the ontology, and it falls somewhere under the negative health outcomes. Now, another thing I wanted to talk about here is that there are solid edges on the graph and there are dotted edges. Now, the solid edges are just, when I link Hispanic and the zip code to this lady who is in the conversation, who is representing the child as their caregiver or parent, so these are things that she already mentioned. And so I started developing, building those relationships between the nodes to say that she is a Hispanic person. She lives in 38103. And so these edges could actually have labels on them to represent relationships. And that's how it becomes a graph. Now, and then when I want to give types, or when I want to attach these data to context, I say Hispanic is a race and 38103 is a zip code, and so on. It does not have to be ISA all the time. It could be HAZA. For example, this individual has a car. Night terror is a symptom, right? Now, I talked earlier about uncovering hidden issues. So she did not really say anything about her child having emotional neglect, but in our ontology that Jan, or my colleague, defined, he defined an axiom in the ontology that says that emotional neglect may cause night terror in children. And so emotional neglect is a concept encoded in the ontology as a concept, but the relationship between emotional neglect and night terror as two concepts is the causes relationship. So this is an example of an axiom. And axioms could be as simple as this, or could be very complicated. This is something, coming from semantic web and predicate logic in math and discrete mathematics. So we have two concepts that are related by a term. So we call them subject, predicate, object. So this is one example. And so in this conversation, if she does not say that her child suffers from emotional neglect, we could actually go ahead and ask her that question next, instead of asking her something from another space. We could just focus the conversation on that aspect. And it's up to her to say yes or no. If she says yes, we could actually just focus on that part and keep asking questions. And one of the famous questions that comes up in the adverse childhood experiences questionnaires is have you recently separated from your husband? So we could ask it in even a more friendly way. It doesn't have to be very similar to the axiom itself. It could be asked in a different way. And that's one example of what we wanted to do. Another example that I wanted to talk about, and it's so I talked about this example of night terror and how we can ask her a question relevant to that. But if, let's say, she said my child is 6 years old, if 6 years old is not really a school age, one of the questions that comes up in the questionnaires is, does your child suffer from bullying at school? If 6 is not an age, school age, if we ask that question to that caregiver, this is irrelevant. But if it is, and we can actually detect that, we can use common sense knowledge graphs like ConceptNet 5. And I know Google detected that 6 is an age in this context, but we could enrich the graph with even more knowledge. So we could actually, it's like double clicking on the node and expanding more and more levels to link age to another concept called school age. So age in this context, 6 as an age in this context, is also a school age. And so it's appropriate to ask that question in this conversation, not in another one. So that's another example of how we actually can do knowledge expansion and also semantic inference. So these are two examples of how we can add more edges and more concepts or nodes to the graph. If, let's say, and this is really interesting, if, let's say, this woman lives in 38103, and I know in the beginning of the conversation of the presentation, I talked about these neighborhood data sets. one of the data sets here talks about things like blight. It's like signs of destruction in the neighborhood and being exposed to toxicants and things like lead-based paint in buildings. There is a very famous score called risk of lead exposure or risk of exposure to lead. And that's something that is considered an environmental factor. And so one thing we could say, if 38103 within our data set, this local repository is marked as a zip code or a census tract or whatever the geographic granular is, if this zip code is considered to have a very high blight rating or risk of lead exposure rating, or a very high crime rate, or a very high, low walkability score, we could actually ask questions to this caregiver based on only her zip code. Even if she doesn't say any of this, we could actually uncover hidden issues. So we could use conceptual hierarchies in the ontology semantic web techniques to detect that 38103 it's a zip code, but it also represents a neighborhood. And a neighborhood has physical characteristics. And one of these physical characteristics is blight, right? Prevalence. And if it's high, we could tell her, we could, even do more inference. We could say, well, a high blight rating could potentially lead to, toxicants in the neighborhood. And things like, lead-based paint in a house is a toxicant. And so we could add a lot of nodes and edges just based on the fact that she lives in this zip code. We can add those concepts and relationships, and then we can go ahead and use the data set that we have, and we can load blight, the concept of blight percentage as a metric with the value. So if it's 80%, then this means it's high. It's like above a certain threshold. And this encourages our agent to ask another question, something like, does anybody in your household suffer from things like asthma, for example? Because I know that being exposed to toxicants as a semantic concept could lead to asthma. And this is based on the ontology. So this is another example of an axiom, just like, emotional neglect causes an adverse childhood experience. Being exposed to a toxicant can lead to a social determinant of health, like things like toxicants leading to asthma. So this is an example of a social determinant of health coming from a neighborhood characteristic that could lead to a negative health outcome, which is a disease in this case. So this is what I meant by using a knowledge graph to detect epidemiological axioms related to causal relationships between social determinants of health and adverse childhood experiences and negative health outcomes, and how they can actually drive certain questions in the conversation. And as you can see here, there are two types of nodes here. There are either questions that we can ask based on uncovered relationships, or actions like, resources, scheduling appointments. And we can benefit from, just like any recommender system, we could benefit from here nationality, ethnicity, race, location, to provide personalized resources. So if Google Places, if I invoke Google Places and it gives me all the clinics in Memphis, I just want the ones that are near here zip code, and provide Spanish speaking services or translation services. The last thing that I wanted to talk about is the design that we thought of the prototype. So basically on this, on the chatbot side, what you can see here is what, is basically it's a chatbot. And as I said, if we reach a stage where we are showing resources, we can use Google Places and Google Maps to kind of show, widgets with some places. If they prepare one clinic or one housing authority within Memphis, depending on the scenario, we could follow that up with an appointment. And once they give us all these details, we could load we can make a reservation on Google Calendar, we can load it in the conversation. I know it's a technology specific scenario, but it could be really applied to anything. What we really wanted to focus on is this AI explainability. And so this is what the user sees, but for the healthcare professional or the social worker, what they could see are things like explanations. And depending on what they want to do, if they are policymakers, they could look at more, things like analytics. So basically, Google Dialogflow has a logging service. And so you could see which conversations went well, which conversation ended abruptly, what was the most stressing issue in those conversations? Was it mostly housing or transportation, etc.? So this is really intended for policymakers. And for healthcare professionals, for explainability, what they could do is, as we were querying the knowledge graph in the back end, they could actually see all the queries that we use. They can see the final snapshot of how the personal graph looks like. We could, as we were detecting things in the agent, based on the intent detection, we could actually show in a friendly way, we could show that, in a summary of the conversation. So this conversation detected risk factors related to housing. In detail, it was mold, etc. The negative health outcomes that came up in these conversations are asthma because of the blight rating in their zip code. Another thing, depending on how much sophisticated the health worker is, they might want to see why we are actually, why we are making those inferences, where are we getting those axioms from. We can lead them to our ontology, the one that we were using for adverse childhood experience, linking adverse childhood experiences and social determinants of health to negative health outcomes. And we can show provenance links. So they could actually click on the link for PioPortal and see, explore the ontology. If we detect 4 issues in ACs, we can give a score. If there were 4 issues, then this person has a score of 4. Not really the person, but their child have an adverse childhood experience score of 4. And we can refer them to literature that links certain scores with certain diseases. And they can click on provenance links. In this case, it's not an ontology, it's a DOI or PMID if it's a PubMed, article. This can pop up if they click on a question mark, for example. And I know this is not the best design, but this is something I thought of. And also, as I said, before we load these recommendations into the chat, we could show them to the health worker. They can actually see them geomapped or geolocated, and they can see them on Google Maps. They can also keep track of all questions that were asked in the conversation. Pretty much anything that was shown on the graph, they can just visualize it. So this is my talk. I apologize if I took longer than expected, but thank you so much for listening.
Nariman, thank you. It was a great talk. We have quite a few questions in the Q&A and also on the chat. Would you like to read them, or would you like me to read them to you to answer?
Yeah, I can. So I will start with the Q&A.
Sure.
Yeah, so how does the chatbot decide that the conversation is not getting anywhere and needs to hand over to a human? That's a good question. So one thing I thought about when I was doing this is, let me go back to, yeah, so you're basically asking what we do when we get frustrated with Xfinity service, right? So like we want to just talk to. So one thing I thought of is, as you can see here, and I think I just, okay. So as the chatbot is talking to the person, the healthcare professional can actually see what the next question is going to be. and it's up to them to decide on just, for like evaluating the, the chatbot for now, because we did not really develop this. We were just, we developed the different components, but we did not really, because we're looking for funding to do that. But they could actually revise. So that probably does not answer your question, but I thought about a stage, where even the, if the question is not ready to be, a follow-up question is not ready to be sent to the user, the healthcare worker or the social worker can actually revise the question before they send it, or they could even, decline the question. But if, depending on how they want to implement this, like the modality, I know the hospital wanted to, what they're doing right now is they're just using this portal to fill these questions. But if they decided to implement it in a way that is similar to what Xfinity does, if they want to be linked to an agent, that could be like the last resolution. And then that would connect them to one of those social workers who are actually handling the Family Resilience Initiative program. So it would be the same thing. Yeah, technically it would be the same thing, but it depends on the application. I don't know if I answered your question.
And the next question is from Edward.
Yeah, in the cases where you have families mentioned, that is, there are multiple people involved, all with their own problems, how does the system determine who to help, the mother, the child, etc.? Actually, I think the way they are doing it right now is one of the caregivers shows up to the interview, and so yeah. So if I understand the question correctly, if let's say the mother is saying, my child suffers from this and that, but I feel like, and some women do it, they say, I feel like I need, I have a low education degree and I want to go to college. And so in the conversation, she talks about issues related to her son and issues related to her. What they do is they actually handle both. They do follow up for her. They provide her with educational, not educational, but like material on how she can actually apply to school and if she needs a scholarship and all of that. And for her kid, if they suffer from psychological issues, they in the same meeting they actually schedule a referral to a psychiatric in within the community. So they do both in one conversation, in one setting. Now for the conversation itself, as I said, when they talk to the woman, and I will just go back to this flow chart that was showing, if she says all of these at once, we will have, I mean, from a technical point of view, we will have to focus on one at a time, and that would activate one context, and we will resolve that first. But before she leaves for the day, we make sure that she gets help, not necessarily now, but like she gets registered or scheduled for all her issues. So your question is valid, and I saw it in the reports.
And the next question is from Anthony. Have you used IBM Watson? If so, what are some pros versus cons between Google Dialogflow and Watson?
Yeah, I haven't used Watson, but I've seen demos on it. And as I said, I think they all share the same, this agent intent definition, context detection and all of that. I think maybe you asked this question before I even talked about this fulfillment aspect, and I think I'm on the right slide right now. I really love, I'm a strong advocate of Google technologies because, when Google started, they started, as like a search engine, and then they had the Google Maps. but then they decided, and I was like following how the Google Cloud Platform evolved. So I really like how they have all these, any application that we use has an API. And so, Dialogflow, it's an app, like you could actually use wizards to play with it, but it has its API. So when I said that I tell Dialogflow about my own taxonomy or ontology, that's how I can actually kind of programmatically do that. So that's one aspect I love about Google. And it's just because IBM is different from Google as a company. But when it comes to chatbots, I know IBM Watson maybe started earlier and it's even more mature, but I love this aspect of being able to call APIs from, within the same environment, if that makes sense. But I don't, I'm not an advocate for one over the other, but I love Google. I'm just biased. How do you decide to be screened for diabetes? Based on my graph, let me go back to, so this is a good question. I couldn't like cover all the examples, but if you look at this graph, again, because this woman lives in 38103, 38103 is a neighborhood concept, and neighborhood as a concept has physical characteristics, and walkability score and crime rate are, some metrics. So they are like, think of these as columns in the Excel sheet. So you have a zip code, 38103 is on one row, and 38103 has different columns for all these metrics. So walkability score would be low, which means that in this neighborhood, and this is actually an issue in Memphis because I lived there, there are neighborhoods where you can't really walk because it's not safe. There is like high crime rate, not just based on the views of it, but like statistics and stuff. And so based on that, I give the example of blight, but if you actually look at walkability and it's really low, what you could do is based on these texts, like the inference based on taxonomy, and then if you load the value from the Excel sheet and if it's low, you could say, well, lack of low walkability in a neighborhood, you could use this axiom, causes lack of physical activity. And lack of physical activity causes obesity, or like high BMI and high BMI, like bad BMI, and then bad BMI causes obesity. And then obesity is a risk factor for diabetes. Then based on this, I would say skeptical causal pathway, you could say, most probably this woman suffers from this, or her child, might suffer from this. You could come up with this assumption, and then to verify that assumption, you could ask the question in the conversation, just like we did with asthma and blight and toxicants. And if she says yes, we will not ask her if your child is diabetic. We will ask her, would you like to be screened for diabetes? We would ask it in that way. And this is something they actually ask, but using their human reasoning, not using ontologies and semantic inference. We're trying to make the machine mimic human thinking. And so that's how we might recommend being screened for diabetes based on neighborhood characteristics. Anthony asked another question. Is most of your time spent on creating the intents and entities for the proper flow? Are there time-specific actions are calling against an API and pulls data from a knowledge graph? So when I created those intents, I really thought about. I know I could be more detailed, but I thought about three things. The first thing I thought about is because there could be either social determinants of health or adverse childhood experiences or interventions. So these are the three main things that I thought about to do at least 3 high-level intents. And these are the ones that I called housing recommendation, or food recommendation, or like these things. And the follow-up activity from this slide, the follow-up activity intent is is an example of an intervention. So when I thought about these, I thought of the ontology itself. So really this taxonomy. And then, within social determinants, I looked at like housing, transportation, all the different things that come in the report, the ones that I was showing here. And I think as we develop the application, if the reports produce more and more, let's say, new subtypes, I would define more intents. It's time consuming at the beginning, but it really helps the conversation go in a certain flow. So the knowledge graph itself is not really intended to be for intents, like driving the chatbot itself. It's more intended for detecting those concepts in the conversation, the words and what they mean, and then running queries and getting results from the data that we have, the data sets that we have, or from Google Places API, and all of that. So I know some chatbots, they use knowledge graphs to kind of like define the this frequently asked questions tree, and I think Google Dialogflow does have that. If you go, and I think it's beta stage right now, but it's different from what I'm doing. I'm doing knowledge graph as a different service to like kind of query the graph for recommendations, not for that purpose. So if that answers your question. Anthony, again, do you have any concerns with using Google technology for healthcare use cases? Industry seems to prefer Amazon. Amazon has HIPAA architecture in place too. Google tends to have trouble with data leaks. Thank you so much. I didn't know that. Yeah, thank you.
Nariman, we can have one final question before it is 7 o'clock.
When you say data sets, does that mean the training data sets, any point you develop with Neo4j? The data sets that I have are these, neighborhood data sets, the metrics, the blight, the vocability, etc. I don't do training in this scenario. The only training I do is what Google does for me. And what I use for training in this case is all the anecdotes that I take from the reports, the text. So I use the text to train the Google agent to do the natural language processing to detect the entity types. I don't, I think it's a different terminologies. The data that I have is the one in Excel sheet that I use to populate the knowledge graph with data about light and these characteristics. And Neo4j, it was there. I was familiar with it, but I know there is a really nice library. I'll share it with you also. It's called KG Lab. It's a Python library for working on RDF graphs directly. You don't need to like use things like Neo4j, but at the time I use it because it's a very famous graph technology.
Thank you, Nariman, for your wonderful speech and presentation. It was great having you here on our meetup. Impressive work. I personally would love to hear more about your work in the future. And we left with a few questions unanswered in the chat. Sorry about that. That means we are going to have a second in the series, Nariman. Okay, for our listeners, if you would like to have a talk on a related subject, please email us at info@magnimindacademy.com and tell us what you have in mind with a brief biography. We would be happy to host you as well for one of our meetups. Until our next meetup, have a wonderful day, everyone.
Thank you so much.
Bye-bye. Sure.